Now we will have a look at the DQN for the fully observable setup. So the first component that we will have a look at is the replay memory. Replay memory has these tuple entries which have a state action, like a stage reward and like the next state. We take one of these entries and feed it into our DNN implementation, and each of the entries has a state action pair. It will get vectorized, and then we will feed it into like the DNN, which will learn the policy for mapping a states to action. Now we will have a look at the loss function. So if you see the loss function, it's what we've learned in class most of the time, right? It just does a temporal difference to get the values of the Q to be slowly updated, which is modulated by a factor of alpha, which will be the step size. Okay, so there's a lot to unpack here, so let's start. Okay, the first most important component here would be the target values. The target values we would get from a target network, and this target network will map to the the part with the stage reward plus the gamma times the max of the Qs. Okay, so that would be the output from say the target network. This will be subtracted from another set of like values of Q, right? So it will be subtracted from the Q values that we are at that point. That is given by like a policy network, and like the policy network is given over here. So when you subtract like the output of these two networks, you will be able to get a delta. This delta will be used to drive the back propagation. It will be used to tune the weights of both the networks till they hit like an optimal point, and they learn like a policy. Okay, so now we have a look at what happens when we start the training. So first, when the training begins, right, if you look at the artificial intelligence agent, the drone in our case, it's kind of wobbly, right? That's because it's doing a lot of exploration in the solution space and trying out a lot of random things. So that's why it's moving about all, like wobbly. And but slowly, if you notice over time, it is trying its best to make its way towards the target, but it fails, miserably by hitting those black block of obstacles. All right, so this will be big torture for our reinforcement learning agent, but it does what it can. All right, so it's trying again and again, getting smashed left and right. Okay. Oh, it got hit by the red block. Okay, so it's trying. But it's learning a policy, right? At least it's learning to move towards where the target is, slowly inching its way towards it. Okay, let's see. Okay, how about that? It's about to hit the target. Yes, it did. Okay, and now it's back to learning again. At least it hit the target once. It's becoming less wobbly. Look, it just circumnavigated around around the red block. Once again, it hit the target. Okay, so it keeps doing this again and again. It has learned something now. Wow, that was neat. Okay, so as you can see, it took a while, but slowly our reinforcement learning agent has been able to learn a policy to kind of dodge the obstacles as much as it can and go and hit the target. So now we have a look at the results. So how the results were taken is I took episodes. So I used a moving window of size 110 to move across all my episodes. So if you see the first square over here, from the first episode at 0 to 110, you see the spikes. What the spikes here represent is the number of times it got super close to the target or it hit the target. You can see like a sparse number of spikes for the first 110 episodes. If we move to the next 110 episodes from 110 to 210, you see the frequency of the spikes goes up. This indicates that our drone is able to hit the target at a higher frequency. So the general trend has been the frequency of the spikes keeps going up with an increase in the number of training episodes, which is indicative of the fact that we are hitting the target more often.